Welcome to Maths Companion. In the last video, we have discussed problems on page 60. Today, let us go to the next part, two chords. Look at this picture. Two diameters are drawn. They intersect at the center. Now, there are four pieces and all these four pieces are equal because they are radii of this circle. That means any two diameters of a circle intersect at the center and the length of the four pieces are equal. Now, instead of diameters, suppose we draw two chords which are not diameters. What happens then? Let us see. Here, two chords are drawn. They intersect inside the circle and there are four pieces. Are they equal? No. But there are some relation between them. To see it, let us join AC and BD like this. Now, these two angles are equal because they are angles made by arc BC on its alternate arc. Therefore, they are equal. In the same way, these two angles are also equal. They are angles made by arc AD on its alternate arc. So, they are equal. That means two angles of this triangle are equal to two angles of this triangle. Means these two triangles are similar. When two triangles are similar, their sides are proportional. Means the ratio between the sides opposite to equal angles are equal. That means these are a pair of equal angles. Which are the sides opposite to them? PA and PD. What is the ratio between PA and PD? PA is to PD, or we can say it as PA by PD. Now let us take another pair of equal angles. Which are the sides opposite to them? PC and PB. What is the ratio between PC and PB? PC is to PB or PC by PB. These two ratios are equal. That is PA by PD equal to PC by PB since the triangles are similar. Now let us cross multiply. PA into PB equal to PC into PD. That means P is the intersecting point. The product of these two parts are equal to the product of these two parts. Or we can say, if two chords of a circle intersect within the circle, then the product of the parts of the two chords are equal. This is a very important result which we have to apply in many situations. Sometimes you may be asked like this. In the figure, the chords AB and CD intersect at P. Prove that PA into PB equal to PC into PD. First of all, let us take the figure. Now join AC and BD. Then take these two angles. Angle A and angle D. They are equal because they are angle made by arc BC on its alternate arc. Angles on the alternate arc. In the same way, these two angles are also equal. Angle C equal to angle B. They are angles made by arc AD on its alternate arc. So, they are also equal. That means these two triangles are similar. That is, triangle ACP and triangle BPT are similar. When two triangles are similar, the sides are proportional. These two are a pair of equal angles. Opposite to them are PA and PD. These two are another pair of equal angles. Opposite to them are PC and PB. Therefore, PA by PD equal to PC by PB. Now cross multiplying we get PA into PB equal to PC into PD. Let us draw a circle and two chords like this. The chords intersect at P. We know PA into PB equal to PC into PD, or product of these two parts equal to product of these two parts. Now let me make a rectangle using these two parts. For that, let me take PA as one side and draw a perpendicular from P like this. Now take the length of PB on it. For that, put the compass at P and take PB as radius and draw an arc like this. Let it meet the perpendicular at J. Then PB and PJ are equal. Now draw a rectangle with PA and PJ as adjacent sides. Now what is the area of this rectangle? We know area of the rectangle is length into breadth, that is PA into PJ. But PJ and PB are equal. Therefore we can say the area of this rectangle is PA into PB. In the same way, let me make another rectangle using these two parts. For that, let me take PC as one side and draw a perpendicular through the point P. Now take the length PD on this perpendicular. For that, put the compass at P and take PD as the radius and draw an arc like this. Let the arc meet the perpendicular at K. Now PD and PK are equal. Let us make a rectangle with PC and PK as adjacent sides like this. What is the area of this rectangle? Length into breadth, or PC into PK. But PK and PD are equal. Therefore we can say area of this rectangle is PC into PD. But we know PA into PB equal to PC into PD. That means the areas of these two rectangles are equal. How did we make this rectangle? Using these two parts. And how did we make this rectangle? Using these two parts. And we have seen that the areas of these two rectangles are equal. That means if two chords of a circle intersect within the circle, then the rectangles formed by the parts of the same chord have equal area. This can be used in different ways. For example, suppose we have a rectangle. We need to draw another rectangle of the same area, but the length is different. Length is this much. We can use this idea to draw the rectangle. For example, suppose PC and PD are the length of this blue rectangle, and suppose PA is the new length, this much. Then PB is the breadth of the new rectangle. Using PA and PB, we can draw another rectangle which will have the same area of this rectangle, and the length of that rectangle is this much. Let us see how to do this using a problem. Draw a rectangle of width 5 cm and height 3 cm. Draw a rectangle of the same area with width 6 cm. This is a part of the second problem on page 67. First of all, we have to draw a rectangle of width 5 cm and height 3 cm. That means we have to draw a rectangle of length 5 cm and width 3 cm. At first, let us draw a line of length 5 cm. Now take 90 degree at P and draw a line. Mark a point 3 cm away from P. Let it be Q. Join PQ, that is the breadth of our rectangle. Now take 3 cm in the compass and draw an arc from A. Take 5 cm in the compass and draw an arc from Q. The intersecting point is the fourth vertex of our rectangle. Join AR and join QR. So we got our rectangle now. Now we have to make another rectangle of the same area with width 6 cm. Let us extend the length AP and take the breadth PQ on it. Now PQ and PB are equal. Now let us extend PQ and take 6 cm on it. Now let us draw a circle passing through the points A, B and D. For that it is enough to draw the circumcircle of triangle ABD. You cannot see triangle ABD here, but if you join AD and BD, you will get the triangle. The lines are not necessary, that is why we are not drawing those lines. Now to draw the circumcircle, we need perpendicular bisector of any two sides. Let me draw the perpendicular bisectors of AD and BD. To draw the perpendicular bisector of AD, put the composite D and draw arcs on both sides. Taking the same radius, put the composite A and draw arcs on both sides. Mark the points of intersections, join them. This line is the perpendicular bisector of AD. In the same way, let us draw the perpendicular bisector of BD. Put the composite D and draw arcs on both sides. Taking the same radius, put the composite B and draw arcs on both sides. Mark the points of intersection, join them. This line is the perpendicular bisector of BD. The two bisectors intersect at a point that is the center of the circumcircle. Now put the composite O, take OD as the radius and draw a circle. It is the circumcircle of triangle ABD. You can see the circle passes through the points A, B and D. Now the circle intersects the line DQ at a point. Let it be C. Now we know PA into PB equal to PC into PD. PB and PQ are equal. Therefore, the area of the first rectangle equal to PA into PB. That is equal to PC into PD. Now if we make a rectangle with PC and PD as sides, its area will be equal to the area of the first rectangle. To make the rectangle, let us take the distance PC in the compass and draw an arc on PB. Let it meet at K. Now PK and PC are equal. Now take 6 cm in the compass and draw an arc from K. Take the distance PK in the compass and draw an arc from D. The intersecting point is the fourth vertex of the rectangle. Join KM and DM. Quadrilateral DMKP is the required quadrilateral. We know PA into PB equal to PC into PD. Therefore, the areas of these two rectangles are same. Moreover, one side of the new rectangle is 6 cm. So we got a rectangle having the same area of the first rectangle with width 6 cm. Let us recall what we have learned today. If two chords AB and CD intersect at P like this, then PA into PB equal to PC into PD. Or if two chords of a circle intersect within the circle, then the product of the parts of the two chords are equal. If two chords of a circle intersect within the circle, then the rectangles formed by the parts of the same chord have equal area. Now there is a homework. In the picture, chords A, B and C, D of the circle are extended to meet at P. Prove that the angles of triangle APC and PBD formed by joining AC and BD are the same. Prove that PA into PB equal to PC into PD. Prove that if PB equal to PD, then ABDC is an isosceles trapezium. In the next video, we shall discuss the remaining part. Till then, bye.